Okay, now let's take a look at the capacitors. Okay, these questions are a little bit more complicated than the questions that is given by professors, so please be patient. Okay, let's get started. Okay, this is a simple capacitance circuit, okay? Okay, first question is explain the time constant. Explain the time constant of the capacitor. What is the time constant? Most of students will answer just two numbers, 63.2 and 36.8. Don't say it like that. Okay, the time constant. I'll say the definition again, so please remember it. Time constant reflects the time required for a capacitor to charge up to 63.2% of the applied voltage, or to discharge down to 36.8%. Okay? The required time for these two situations are time constant. Okay? Is time constant. Okay? The time constant is expressed as T. Actually, sometimes we use tau, but it depends on the textbook, so I'll just use T in this lecture. T looks a little bit weird. Yeah, T equal resistance multiplied by capacitance. Okay? So this is the formula for the time constant. Please remember it. Let's move on to the B. If the circuit is in a capacitor charging process, how much voltage will be charged? Set up the equation. So, we should just use, these things. There's no numbers in this circuit. Also, you can think that ET is equal to VT. So ET is also meaning the voltage. In United States, we use E to represent the voltage. So actually E and V is the same meaning at the circuit. Okay, that's not the important thing. So the total voltage is Vt, and the capacitor's charged voltage is same as calculating the voltage drop. Okay, so if you want to calculate the voltage drops of the C1, what should you do? Yeah, due to the Kirchhoff's voltage law, you will write equation like this: total minus voltage drop of R1. Okay? Yeah, and actually this is the charged voltage of the capacitor. And it will be just like this. Yeah, I just used Ohm's law to explain it more in detail. So this is the equation what I want. Let's move on to the next question. If the circuit is in a capacitor discharging process, in this time, discharging, how does capacitor affect the resistor? So, in discharging process, the circuit would look like this, right? So, how does capacitor affect to the resistor? Yeah. When a capacitor discharges through the resistor, the capacitor's stored energy gradually dissipates as current flows through the resistor. So, in discharging process, capacitor works like a kind of power supply. Okay? This is a very important information, so please remember it. So I'll just write down it works like a power supply. It's not a exactly power supply because it is decreasing, but to understand you guys very easy, to make you guys understand very easy, I just use a word power supply. Okay, this is all the question of number 4. Let's move on to 5. Yeah, this is a little bit complex question. The switch SW2 has been open for a long time. In this case, long time is meaning almost infinity. Okay? For infinity of time, the switch 2 has been opened. But now, we'll suppose that the switch SW1 opens and the switch 2 closes at the same time. And that same time is t equals 0. Okay? Then, what the current is flowing at t equals 0. So let's first think about when the S2 is open and S1 is closed. When S1 is closed and S2 is opened, the capacitor becomes an open circuit, right? This is an open circuit, right? So you can just think there is no connections over here. It is just an open circuit. Because of the charging process of the capacitor, the current cannot flow over here, right? When the capacitor is charging, current cannot flow over here. So it is exactly a open circuit. You should remember like this, understand like this, okay? Anyway, the capacitor becomes an open circuit, so in this open circuit, the current doesn't flow, but all the components have a voltage drop, right? So, in this case, what is the capacitor's voltage drop? The first task is finding the capacitor's voltage drop, okay? First, this resistor will have a voltage drop 2 volts. Do you agree with it? You should understand it. And capacitor will receive 10 volts. Okay? Good? Good. By the way, these ones voltages are actually only from 10 volts, right? Because these two resistors and capacitor is in parallel, so the sum of these two resistors, the voltage sum of these two resistors and the voltage of the capacitor should be same. Therefore, this will be 4 volts and this will be 6 volts, right? Yeah, this is very just a natural phenomenon. Okay, this is all the explanation of when the switch 2 is open and the switch 1 is closed. Okay? Okay, let's say, suppose when the time reaches t equals 0, switch 1 will be opened, just like this, and switch 2 will be closed. Okay? So switch 2 is closed, and this is also meaning that current doesn't flows over here. So only you should think about this part. Okay? Only this part the current is flowing. Therefore, the flowing current will be 4K and 10 volt over 4K. Okay? And it is 2.5 milliampere. Okay? So the first one's answer is this. Next, calculate the discharging time constant of the above circuit. So, this case is discharging process, right? So, let's use the equation. T equals R times C. So, what was R? Yeah, 4K. What was C? C was 200 microfarad. 200 microfarad. And if you calculate this value, it will be 0.8 second. Good? Okay. The explanation of the capacitor is over. So the final question is about input, output resistance, reactance, and impedance. Let's just do it in this lecture. First, input resistance. This term refers to the resistance seen by a signal source when it is connected to the input terminals of a circuit or devices. This value determines how much the input voltage or current change concerning changes in the source's voltage or current. Okay, so high input resistance minimizes the loading effect on the source, allowing efficient transfer of signals without significant loss or distortion. Okay, this is the brief explanation of the input resistance. If you have any questions, please ask me. I'll go next to the output resistance. This refers to the resistance that a device presents to a load connected to its output terminals. Actually, yeah, input resistance is connected with input terminals, and output resistance is connected with output terminals. A lower output resistance means the device can provide more significant amount of powers to the load without substantial voltage drop or distortion. Okay. High output resistance can cause signal degradation, affecting the efficiency of power transfer to the load. Okay, so question A and B, you should just focus of the characteristics of input voltage and output voltage. Okay, let's move on to question C. Okay, question C. Actually, reactance only focuses on AC circuit, so this is the big difference. But there's other differences also. First, resistance opposes the flow of the current regardless of the frequency of the signal, dissipating energy in the form of heat. So, the kind of output of the resistance is heat. Okay? And there's no effect with frequencies. Okay? However, reactance arises from the presence of reactive components like capacitors and inductors. So, capacitors and inductors are causing the reactance. Okay? This was reason. And also this value is frequency dependent. So it affects with frequency, influence the way these elements respond to alternating currents by either storing or releasing energy. Okay? So this is the basic differences. Okay, final question. What is the impedance? Impedance is the combined effect of resistance and reactance. Okay? And this is usually symbolized as Z. Impedance is the ratio of voltage to current in an AC circuit. Okay? So this is just a definition of the impedance, and impedance must be used to calculate the current in a reactive circuit where the supply voltage is known. Yeah, I think that's enough. Okay. Finally, we finished all of the questions. Thank you for listening my lecture, and have a nice day. And also have a good luck with your exams. Thank you.